This one video will change your entire perspective towards flight delays. Delays, whether they happen during the takeoff or during the landing, are very frustrating. As a passenger, I totally understand as well as empathize with you. However, don't you think that all of us should pause for a moment and think about this situation from an air traffic controller's perspective? As an aspiring ATC, I always wondered why ATCs stop the clearance for certain flights during takeoff or during landing. Well, there are multiple reasons for that. But today we're going to be talking about one such important reason why flights are often delayed. And that's none other than wake turbulence. Hello everyone, my name is Pranavi. Welcome back to my channel Avgeek Diaries. Today I am going to be teaching you about what a wake turbulence is, how does it occur, and how to prevent it. Well, we can't exactly prevent it, but there are some things called as separation standards given by DGCA as well as ICAO. Alright, here we go. As you can see the picture on the screen, I have particularly taken this picture because you can clearly see wings in this picture. And this wake turbulence has to do a lot with wings of the aircraft. Before I dive into wake turbulence, I would like to give a brief gist about what turbulence is. Now, turbulence is nothing but violent and unpredictable winds which cause the aircraft to either roll towards its right or left, or in some cases shake violently. Turbulence is of different types, but I have broadly classified it into one is the most common one which we have often seen, heard about and experienced too. That is nothing but mid-air turbulence. While the second one is what we're going to talk about today, wake turbulence. That is nothing but when a flight undergoes a stream of clouds or is having an extreme bad weather due to which the flight shakes slightly. However, they're pretty much harmless if the pilots are skilled and they can put through the air smoothly. And if the pilot avoids routes which have thunderstorms, and also if the ATC gives proper navigation and waypoints to the pilots such that they avoid areas prone to turbulence. So that's how mid-air turbulence can be handled, and most of the times it's pretty much harmless. However, this wake turbulence is something which is very concerning. It's dangerous as well as deadly. In the past, there have been scenarios where aircraft have crashed due to this wake turbulence. And the interesting part about this is that that's not even its aircraft fault that it has crashed. One aircraft crashes cause of the turbulence caused cause of other aircraft. Let me explain this in a clear manner. Imagine a heavy aircraft landing. Let's say maybe Airbus A380. Now Airbus A380 has landed. Now because it is a heavy aircraft, it forms this wake turbulence. Due to this, if a small aircraft such as maybe Cessna 152 had to follow it, then it has to wait for some time in the air before landing. If it lands immediately after that, there are high chances that Cessna is going to crash. It's definitely going to experience violent shaking and rolling towards one side. Apart from that, there are high chances that it will crash. To avoid this, DGCA as well as ICAO have come up with something called as separation standards, which we're going to talk about soon. But before that, let's actually understand why this wake turbulence occurs. Now we are going to finally use this figure on the screen. I'm going to annotate it because it'll be easy for you to understand. Now this is the wings of the aircraft, right? This is the upper surface of the wing, whereas this part below it is the lower surface. As we have learned in aerodynamics, lift is an aerodynamic force which is caused due to the upper and lower pressure differences of the wing. And as we know from basic physics as well as basic chemistry, that air pressure is something which is less on top of the wing and low below the wing. And also that the pressure, the air, it moves from high pressure area to low pressure area. So the air would probably move like this from downwards to upwards, because downwards we're going to have high pressure area, upwards we're going to have low pressure area. Like that, air moves, and this causes violent and powerful spinning set of wind. And these sets of wind, they are called as vortices. Now these vortices are very much dangerous. The intensity of vortices are compared to that of mini tornadoes. So that is why it makes it dangerous, due to which the impact of this vortices not only spreads across the wings but also spreads to 10 times that of the wingspan. Now wingspan is nothing but the length of the wing. This is the fuselage, right? This is the fuselage and this is the wingtip. So the length of the wing, which is from its fuselage till the wingtip, that is called wingspan. So it not only spreads from the wingspan but spreads beyond it. Sometimes 10 times beyond the wingspan, and in some cases 20 times beyond the wingspan. Due to this, the air will keep circling around, and it circles around the entire runway. And the separation standards, which I stated earlier, they are based on assumption that the takeoff and landing is happening on the same runway. There are also separate set of rules if the takeoff and landing happens on the parallel runways or the intersecting runways. Due to this, yeah, as I've mentioned, the entire runway, the wind spreads over the runway. Now, these winds get cleared up by themselves within 2 to 3 minutes. However, if there is light breeze, then they take time to get dissolved and move away. But if there is heavy wind and heavy breeze, then that will move it away from the runway, making the runway now safer for the next aircraft to land. Now let's know aircraft is more prone to damage. The answer is lighter aircrafts. The reason is basically aerodynamics, because we know that lift is a force which acts opposite to that of weight. That means for an aircraft to fly, it has to overcome its weight in order to fly. That means the lift has to be of much more greater value than its weight. Now for heavy aircrafts, more lift is needed to fly. Whereas for small aircrafts, small lift is needed to fly, which means that small changes in winds can directly affect the small aircrafts. Like this vortices, which are violent winds, they directly affect that of small aircrafts. They completely push the small aircraft away from the runway, and that is exactly the reason why these small aircraft crash if they land immediately after a heavy aircraft. Let me give you an analogy so that you can understand this concept better. Imagine there is this bulky, well-built senior in school, probably a 10th grader. And imagine there's another person who's a junior, who's not that well-built, who's kind of weak, not so muscular, not so strong. Maybe, let's say, a second grader or a third grader. Now imagine that this 10th grader, the bulky senior bully, pushes away the second grader. Obviously, the second grader would get hurt, right? This is something similar to this. If a heavy aircraft such as A330 lands and Cessna 152 has to wait for at least 6 to 8 minutes to land, so that the entire wind gets cleared up and the runway is safe for it to land. Now we're going to dive into the separation standards of wake turbulence. Now these are separation standards of DGCA as well as ICAO. Now this one right here is the aircraft which has landed, the first column. The second column is aircraft which is yet to land, and these are the miles, separation in miles and separation as well as minutes. Now if a heavy aircraft has landed, for another heavy aircraft to land, for example A380 has landed, for Boeing 737 to land, that means the Boeing 737 has to wait for at least 2 to 3 minutes, and then they only land, or else it has to maintain a distance of 4 to 6 miles as seen in the radar system. And for similarly, if A380 has landed and a medium aircraft has to land, suppose A320 for example, if that has to land, then it has to wait for same 2 to 3 minutes, but it has to maintain a greater distance of separation, which is 5 to 6 miles of separation. Reason is, as I mentioned, the weight plays a huge role in this. So if the weight of the aircraft is less than the one which has already landed, that means it is in higher risk of it getting prone to turbulence and ultimately having a crash landing. So to avoid that, these are separation things. And I've already spoken about the light aircraft many times in this video, that if a light aircraft has to land, what are the criteria. So this is what is all about the separation standards. And these separation standards are according to the assumption that the landing and takeoff is happening from the same runway. Now assume that we have landing and takeoff happening in parallel runway. Now as I've told that it spreads so much that this violent winds, they spread so much across the wingspan, so the entire runway is unsafe for a couple of minutes. isn't it? Now, if there's a parallel runway, imagine this hand is one runway and this hand is another runway. Imagine if the distance between these two parallel runways are less. That means I'm talking about if the distance between these two runways are less than 800 meters, then there's absolutely no problem and no need to follow the separation standards here. However, if it is less than 800 meters, that means that has to be considered as if it is happening on same runway, and that is how it has to be done. The separation standards have to be given. Now, if there is intersecting runways or crossover runways, that means intersecting runways and crossover runways have more risk, or like almost same risk as landing in the same runway. So the exact same separation standards maintained. So that is how the pilots and ATCs should manage this to avoid a crash landing. Watching this video, to know what more interesting things, subscribe to my channel, and very soon I'm going to be posting a case study regarding the same concept. So consider this video as a prequel to the video which I'm going to be posting soon. Also, I hope that now you've finally understood why ATC gives ATC delays clearance for landing as well as takeoff. So the next time your flight is delayed, please don't get frustrated. In fact, send a silent prayer to that ATC, thanking them for indirectly saving your life.